Welcome back to the deep dive. Today we're looking at something pretty complex, but increasingly common. Large-scale commercial AV distribution. Think big video walls, lots of screens. Yeah, we've got sources detailing specifically the WolfPack 4K 30 Hz AV over IP matrix switchers. These are systems designed for like up to 50 TVs. So our mission today is to really get our heads around tech, the architecture, and what makes these big networks tick.
It's a great topic because the AVO-IP, that's audio video over IP, is really shaking things up in commercial installs.
Mm-hmm.
It wasn't that long ago, maybe 10 years, if you wanted 50 screens. Oh, man.
Right.
You were looking at incredibly long, thick, expensive copper cables, maybe fiber, all leading back to this one giant central switch. A single point of failure, really.
Right, nightmare stuff.
Exactly. So AVO-IP, which is what this WolfPack system uses, it kind of ditches that whole model. It leverages standard Ethernet networking. The same cables and switches running your office network, your internet.
Yeah.
And it uses that infrastructure to send high-res video 4K, in this case, and audio. The real beauty is, by treating video like network data, you get, well, huge scalability and flexibility.
Okay, so let's unpack the architecture then. How does it handle that scale? They use a 14 by 32 system as an example, 14 sources feeding 32 screens. Normally, that would mean a big chassis full of input cards, output cards. Gets messy.
Right, but here it's simpler, physically at least.
Yeah.
You have transmitters, the TX units, and receivers, the RX units. TX connects to your source, like a cable box or media player. RX sits behind the TV. Pretty standard so far.
But here's the bit I thought was really smart, operationally speaking. The transmitters and receivers, they're the same physical box.
That is huge.
Yeah.
Think about it from an installer's point of view. Inventory management, spares. It's a headache keeping track of separate TX and RX units.
You end up with a box of spares you can't use.
Exactly. Here you order one thing, they call it a transceiver. And then on-site, using software, you just tell it, okay, you're a transmitter or you're a receiver. It simplifies everything, ordering, stocking, even troubleshooting in the field.
Okay, clever. And what connects them all, they mention needing a PoE Ethernet switch. Power over Ethernet.
Mm-hmm. Typically, yeah, for a decent-sized install like that 14 by 32, you might use a 48-port PoE switch.
And PoE means the units get power through the network cable itself, right?
Correct. So you don't need a separate power outlet behind every single TV for the receiver unit. Cleaner installation, less electrical work, big win.
And crucially for scale, they say you can cascade switches, link them together.
Yeah, that's fundamental to how AVO-IP scales beyond a single switch. You're not limited by, say, 48 ports. Need more. You just connect another switch to the first one and another to that one.
Okay, that explains the scalability claims. Though, I gotta say, some of the language in the source material, like unlimited sources, unlimited HDI ins and outs, unlimited KVM, that sounds a bit like marketing speak, doesn't it?
Well, yes and no.
Mm-hmm.
It's marketing, sure, but it points to the architectural difference.
Mm-hmm.
In the old world, your matrix switch had, say, 16 physical input ports. If you needed a 17th source, you were stuck. You needed a bigger switch.
Right, rip and replace.
Exactly. With AVO-IP, the unlimited means there's no inherent limit in the system design itself. Need another source? Just plug another transceiver, set as TX, into an available port on your network switch. The system can route it.
Ah, okay. So the real limit isn't the AV system, it's the network infrastructure you build, the number of switch ports, and the overall bandwidth capacity of those switches.
Precisely. The bottleneck becomes the network switch's backplane, how much total data it can handle simultaneously. But the concept is non-blocking. Any input can, in theory, reach any output without hitting a hard limit in the AV distribution part itself. You scale by adding more network capacity.
That makes more sense. It's unlimited in potential, limited by practical network deployment and budget. It's inherently future-proof in that way. Okay, so the hardware's flexible. But what about performance? You're sending video over a network, which used to be a recipe for, well, problems. What are the key specs here?
Performance is always the big question with AVO-IP. The specs they list are interesting. First, video quality. They skate 4K resolution at 30 Hz, 30 frames per second.
30 Hertz. Most TVs or sources now are 60 Hertz, aren't they? Why 30?
Ah, that's a really key insight. It's all about bandwidth management. Pushing full 4K video at 60 frames per second requires a lot of data. You typically need a 10 gigabit network infrastructure for that, which is significantly more expensive than standard 1 gigabit Ethernet. By using 4K at 30 Hz, they cut the bandwidth requirement roughly in half. This allows the system to run smoothly over standard, much cheaper 1 gigabit switches, which are ubiquitous in commercial buildings already. For most commercial content, digital signage, news, even sports in a bar, 30 Hz is perfectly fine. You likely wouldn't notice the difference. It's a smart engineering trade-off for cost effectiveness.
Got it. 4K quality, but optimized for standard networks. What about keeping that signal secure and efficient? They mentioned H.3065 and some security compliance.
Right. H.265 is the compression codec high-efficiency video coding. It's very good at squishing that 4K data down to fit on the 1G network without you really seeing any quality loss. Very efficient.
And the security, HDCP and SEC security.
HDCP is standard, high bandwidth digital content protection. It's required by content providers like Blu-ray or streaming services to prevent copying. Your system has to support it. The SEC security likely refers to network-level security protocols, ensuring the streams aren't easily intercepted or tampered with on the local network, which is important in corporate or government settings.
And physically, it all runs over standard SNEET6 network cable, up to 450 feet.
Yep, standard inexpensive CT6. That 450-foot distance is huge. Compare that to HDMI's practical limit of maybe 50 feet without expensive boosters, or those old, thick coax cables. It's night and day for installation flexibility and cost.
Definitely. Okay, so picture quality is good, cabling is easy. What about delay, latency? That seems critical if you're watching something live.
Absolutely critical, and this is where the source material gives a really impressive number, 80 milliseconds for both switching time and latency.
80 milliseconds, is that good?
That's very good for AV-over-IP,
Yeah.
especially at this price point. To give you context, human perception of visual lag really starts somewhere around 100 milliseconds, maybe a bit more. So at 80 mils, the delay between, say, a sports play happening and seeing it on the screen or moving your mouse in a KVM setup is essentially imperceptible.
Wow, okay, so it feels instantaneous.
Pretty much. That low latency makes it suitable not just for watching video, but for interactive stuff too, like controlling remote computers where you need immediate feedback.
And logistically, they mentioned the units are rack mountable, standard stuff, and separate audio outs.
Yeah, rack mounting is essential for clean installs in equipment rooms. The separate audio outs are important too. In many large venues, the sound system is managed totally separately from the video displays. You need to be able to pull the audio feed out from a specific source and send it just to the amplifier system, independent of where the video is going. This allows that.
So we have this flexible, scalable hardware, great performance, but how do you actually use it? Managing 50 screens sounds daunting. This is where the control system comes in, right?
Control is everything in a system like this. Because it's all network-based, the control is software-defined. It makes managing complex setups much easier.
Like the video walls they mention, any size, any quantity.
Exactly. You can tell the software, these 4 screens act as one big 2x2 display, or these 3 screens are a vertical banner. The system then treats that group as a single destination. You can drag and drop a source onto the entire wall, and it automatically splits the image correctly across the physical displays. Super flexible for creative layouts.
And how do you actually do the dragging and dropping? What's the interface?
They list several options. WIA-Fi apps for your phone or tablet, iOS or Android. There's also PC software for more detailed configuration and control.
But the source highlights one thing that sounds like a game changer for, say, a bar manager. iPad real-time video preview of all sources. What does that actually mean in practice?
Okay, this is the aha moment. Imagine you're running that sports bar. You've got 10 different satellite receivers, maybe a couple of PCs showing schedules, whatever.
Right, lots of inputs.
Traditionally, to see what's actually playing on Source 3, you might have a tiny monitor wall in the back office, or you'd have to route Source 3 to a nearby TV just to check it. Huge pain.
Yeah, I can see that.
With this real-time preview feature, you pull up the control app on your iPad. You see a grid of small live video thumbnails showing exactly what each of your 10 sources is outputting right now.
Live on the iPad.
Live. So you glance at it, see, source 3 showing the right game, tap that thumbnail, then tap the TV or group of TVs you want to send it to. Done. Instantly. No guesswork, no running back and forth.
Yeah, that makes managing a complex system incredibly simple. You see everything at once.
It transforms the system from just infrastructure into a proper operational tool. And they take it even further with the optional add-on they detail.
Ah, the optional sports bar system. This sounded like a layer on top of the core of OVIP system.
It is. It's specialized software that integrates control of the sources themselves into that same iPad interface.
So you're not just routing the video signal, you're actually changing the channel.
Exactly. The source says it supports controlling major providers. DirecTV, DISH, cable boxes, even Roku. So from the iPad app, you see your floor plan. tap a TV, and not only wrote a source to it, but also changed the channel on that source device, all from the app.
Okay, that is slick. No more hunting for 50 different remote controls.
None. It shows you the TV listings, manages audio zones, routes video. It's the unified command center for the whole venue's AV, run from a tablet.
So shifting gears a bit to the business side. This sounds powerful, but potentially expensive upfront. What about ongoing costs and future expansion?
Two key points in the source material stand out here. First, and this is significant in the software world, no monthly license fees.
Oh, that's good. Some systems nickel and dime you with ongoing software licenses.
Some do, yeah.
Yeah.
Especially for advanced features or per stream licenses. The system being free of those ongoing operational expenses is a big plus for budgeting.
And the second point.
Scalability again, but framed as unlimited field upgradable, which really just reinforces what we discussed earlier. You start with the system you need, now maybe 8 sources and 12 TVs. Next year, you add 4 more TVs, you just buy 4 more transceiver units.
For $250 each, according to the source.
Right. You buy the units, plug them into your existing network switch, assuming you have ports, configure them via the software, and boom, your system's bigger. You don't need to replace the core components. Your initial investment is protected.
And the company behind it, WolfPack, that's a brand of HDTV Supply, Inc. They've been around a while.
Yeah, the source note's 24 years in business, certified way back in 2003. So they're not a startup. They have history in the AV supply space.
Which probably explains the pricing structure. That $250 transceiver is the basic building block. But a full system, like the 16 by 50 configuration they list, that's over $17,000.
Correct. That larger price reflects not just 66 transceiver units, but also the necessary high port count PoE switches, maybe control hardware, software configuration, etc. It highlights that the cost scales directly with the size and complexity of the installation.
Which is why they offer build your own and custom quotes. Every venue's needs are different.
Exactly. You tailor it to your specific source count and display count.
Okay, so let's try and synthesize this. We've taken a deep dive into this WolfPack AV-over-IP system. What are the big takeaways for you, the listener?
It seems to be about radical flexibility built on standard IT infrastructure. You get 4K video, albeit at 30 hertz, over regular 1G network switches using simple Cat-T6 cable. The unified transceiver simplifies installs. And the control, especially that live iPad preview, seems incredibly powerful for managing complex multi-screen environments. I think that sums it up well. It's a system defined by software, running on standard hardware, achieving high performance through smart compromises like 30 hertz, and offering genuinely useful control features. But if we pull back from this specific product, what does it tell us about the future trend? For decades, big AV projects meant pulling specialized, heavy, expensive cables. HDMI, component coax, whatever, limited distance, inflexible. Now, we see a system using cheap standard SAT6 network cable, achieving 4K with imperceptible 80 ms latency, scaling almost infinitely just by adding network ports and controlled via a tablet. So the provocative thought I'd leave you with is this. How long before dedicated point-to-point AV cabling of HDMI runs become essentially obsolete for any large commercial installation? Are we heading towards a future where the only infrastructure wire you need to pull is standard network cable, and everything else, video, audio control, power, just runs over the IT network? This technology suggests the future might be closer than we think.
A future built entirely on the network switch, something to definitely think about. That's all the time we have for this deep dive. Thanks for joining us.